But with that being said, we learned a ton. So let's do a recap of everything we learned. Whoo, sit back. All right. We deployed a provably fair raffle, a provably fair lottery. This is crazy exciting. Now you should ask the question, does it ever make sense for you to play another lottery that isn't on the blockchain ever again? And the answer is no, because no other lottery is going to give you the transparency of true randomness that the blockchain is. We created this lottery contract. At the top, we've got a whole bunch of custom gas efficient errors, including one that takes many parameters. We learned about type declarations like enums that have different values that can also be wrapped as uints. We made some beautiful events and state variables, all of them starting off as private, and we made getters for the ones that we wanted at the bottom. Oh, so nice. We have this verbose constructor so that no matter what chain we want to deploy this contract on, we can adjust the deployment parameters so that it works flawlessly. Additionally, it'll work flawlessly if we're forking a testnet, if we're forking a mainnet, etc. All we have to do to update for a different network is to add a different network config. That's it. We created a raffle that emits a log to make migration easier and make front-end indexing easier. We worked with Chainlink automation to automatically call our smart contracts. And in fact, if I flip back over to our automation upkeep and I do a little refresh, we scroll down, we can see that it ran once because the perform upkeep was indeed met. It hasn't run again because why? Because we have this check. It doesn't have any players. It can only run if it has players. So the check upkeep checks if it's time for a new lottery draw, and then perform upkeep actually kicks off the lottery draw, which kicks off a call to a Chainlink VRF. This function call is called by an external party. It's called by a group of Chainlink nodes for us. We could call this ourselves, but we're lazy. We want automation to take care of it. We want the decentralized Chainlink network to take care of it. Once it kicks off, the Chainlink VRF will respond and end up calling this fulfill random words, which picks our random winner. And this function we learned about the CEI, checks effects interactions pattern, where we do our checks first. We didn't really have any checks here. But then we do all our effects on the contracts, and then finally our external interactions outside of our smart contracts. Then we have a whole bunch of getter functions. This code base was really only 200 lines of code, but yet it felt like it took so long because we learned a ton of really advanced scripting and deployment methodologies. So we deployed our contract using our helper config so that no matter what chain we deploy this on, it's going to work flawlessly. If we work on Sepolia or another mainnet, we just add the parameters in here that we want. If we work on Anvil, we deployed mocks, fake contracts for us to interact with as if we were working on a real chain. If we don't have a subscription, we programmatically created one in our script. We scripted in Solidity. Insane. Then we started our broadcast and actually deployed our raffle ourselves. And then finally, we added a consumer programmatically to our VRF. Probably also could have added an upkeep to the Chainlink automation, but we didn't have to do that for our testing because we could just pretend to be Chainlink automation ourselves. We created this interactions bit so that we could run commands to add consumers, fund subscriptions, or create subscriptions right from our command line, much easier than having to work with cast. We wrote a lot of unit tests. However, we still left some testing for you if you want to go back and level this up. We worked with a mock Chainlink token. We learned some really interesting testing skills, such as being able to capture the event outputs to use them later in our tests, skipping a test based off of the chain ID. We doubled down on working with modifiers. We expected a revert with this ABI.encode selector thing, which we're still not sure what it does, but we'll learn about it later. We did some perform upkeep and all these other tests. And then at the end of this, you didn't have to do this, but I went ahead and did this, but I deployed this lottery on chain onto an actual testnet. We funded our automation subscription with Link. We funded our VRF subscription with Link, and we saw the Chainlink nodes take care of all of this, no problem. Whew. This was a large project, and we did a lot of coding here. If you made it to this part of the course, you should be incredibly proud of yourself and give yourself a massive pat on the back. Take some time right now to go on a walk, do some push-ups, do some pull-ups, go get some ice cream, go grocery shopping, take a break, post about this on Twitter, post this to your GitHub. This is an awesome project to post to your GitHub, by the way. Post to your GitHub and be excited that you've made it this far. If you're in the GitHub repo associated with this course, you know that we have a lot of lessons left. However, getting this far is a phenomenal achievement. And like I was saying, you have the basics of Solidity knowledge down. The next couple courses are going to teach you more intricate knowledge about the Web3 ecosystem itself. So take that break, and I'll see you soon.